Final thing I want to talk about is future applications of big data, and this is also a place that I think is really exciting. So basically, what I believe here, I think, and a lot of people believe, is that the most impactful applications of big data for society are still nascent. They're still very early on. And these really impactful ones are things like large-scale science, using big data tools to understand scientific data around us, personalized medicine, in general, using all the information we can sense about a patient to actually design really great therapy for them, and also civil applications. So can you use it to improve, cities, as Randy was talking about? Can you use it to monitor transparency? Can you use it to actually improve society? Because there's now a lot of data available that could come in to do that. So as one example of this that I think is really a great example that started in the MLflow is the MLflow genomics effort that was led by Dave. So we became interested in genomics because we started talking early on with for example, various medical researchers that wanted to use our big data tools, and we put together, or I should say, Dave put together a group of people from 5 different institutions. You had the MLflow, Microsoft Research, UC San Francisco, and later OHSU in Oregon, and also UC Santa Cruz. And this group had a lot of great discussions and a lot of really interesting impact on a bunch of the real medical and scientific applications these were doing. One of the things that happened very early on that shows how impactful this will be is Dave's article in the New York Times on computer scientists may have what it takes to help cure cancer. And basically his argument was that if computer scientists actually have some of the skills required for this, aren't we actually obligated to do it if it can have so much impact on the lives of people? And it's obviously a big goal to try to do this, but I think the things that happened in this effort actually took some meaningful steps towards that. So just this effort, which I think started probably in 2012 or 2013, pretty recent, already has led to a lot of really great software. So for example, Atom is a toolkit for genomic data processing that came out of the MLflow, where basically they said, let's take the file formats and processing systems that are industry standard in places like Hadoop, and let's just put genomic data in them. And when you did that, you actually could make the data a lot smaller. It actually compressed better than the specially tailored formats that biologists use themselves, just by putting it into a standard Hadoop data format, and you could also operate on it a lot quicker. And Atom is used in a bunch of other projects now at different research institutions. Snap was a high-speed sequence aligner that actually I also helped work on, that was used for things like identifying new pathogens and also building new pipelines, for example, for sequencing RNA. And Avocado is a distributed variant caller based on Atom that can do the main computational task in sequencing a human genome a lot faster. And another thing that I recently learned in this area is that the Broad Institute's GATK, which is the most widely used pipeline for genomic data processing, now uses some of this AMP technology. It actually, for example, they're changing the GATK to run over Spark in parallel. So it's really cool to see other groups using this technology as well.